and gentlemen, that was an introduction to a modern MacBook Pro. Everything's USB-C these days, which means it's UC nothing, actually. My name is Tyler, and I'm a software engineer for Nested.com. Nested is a new tech startup in London that's seeking to change the UK property market by guaranteeing you a fair price for your home in 90 days, or we'll pay you the money ourselves. Not me, of course, but the business. So today, we're going to talk to you about a recent challenge we hit, which was converting Nested.com to a single-page application from a multi-page Rails application. Tech drives a lot of what we do at Nested. We needed to build our internal evaluation and agency tools. We needed to help make sense of the huge amounts of data in the UK property market and try to gain insights into that and build some valuation models for that as well. And obviously, we also use it to flesh out our marketing site and try to get our brand out there and try to get as many people to know about us as possible. That last part's what I'm going to talk about today. Probably should have shown you that. That's our homepage. That's what we're talking about. So where did we start? We started with a rudimentary stick diagram that I've drawn here, and a server on the right, if that's not quite clear. But we started with a multi-page, pretty traditional Rails application. The idea here is pretty simple. You would request a page from Nested.com. The server will respond with some HTML, which is in red here. The user would then click another link, maybe a How It Works link. And then, again, the server would respond with another page. This request-response cycle is going to happen for just about every interaction the user has. It doesn't feel extremely fluid. It will trigger a full-page refresh every time you do anything. And generally, we're trying to move away from that. So where are we trying to get to? Well, we're trying to get to a normal React application that we've all seen, know, and love. So a user would navigate to Nested.com. The server would, again, respond with some HTML as well as some JavaScript this time. We'll render some view based on that using React. And then you'll see these dashed lines going back and forth, which represent possibly more AJAX calls for some data or for some additional chunks from the back end or some other thing. But the main takeaway is that most of the navigation is now being handled by the front end now. So when you click a link, like How It Works or whatever, that'll be a view that's dynamically updated rather than triggering a full page refresh. So that's all well and good. We've all read plenty of tutorials before or watched talks before about people doing either of those things. And you'd be led to believe that in our infinite wisdom in the world that we always make the correct decisions first time round, and we decide, sure, we're going to make a React application from the start and everything's great. But in reality, you tend to start with one thing, you tend to change your mind, maybe you find out you made a mistake, maybe you back out because someone you're intimidated by told you to, and you end up somewhere halfway between. So what we want to talk about today is how do we manage that halfway between stage? How do we make it sane? How do we enjoy our lives while we do it? And how do we not punish the user along the way? So in order to do this, we need some goals. We're going to have 3 goals. Main goal number 1, we want to get results out to users quickly. So there's actually a decent amount of risk in just ripping apart your front end and deciding you're going to throw something else at it. You could spend a few months maybe moving it all across, depending on how much functionality you have. Or you could try to get it out piece by piece and encounter a lot of the issues you're going to face along the way and try to solve those issues before they become massive problems. So yeah, hopefully it won't be baked into decisions as you do this on a sort of, I don't know, week-by-week basis or sprintly basis. And that's the main idea. So the outcome here that we decided to go with is we'd build out functionality 1 page at a time. So we'd start maybe with the home page and build it in React, and then we'd move on to something like our How It Works page or various other pages, properties pages, and build them in React while continuing to serve the older pages with Rails. Main goal number 2, we want to make sure it's working. It's a live site, so it might seem like a great idea just to get out there and roll your sleeves up and get something done. But in reality, we want to make sure that the thing we're doing actually isn't having a negative impact on our day-to-day running. So there's a few ways you can do this. Well, actually, there's a few benefits of this, one of which is you can turn something, what we want is to be able to turn something off straight away if it's going terribly wrong. If for some reason we find that actually we've lost all of our customers based on that last feature, it'd be quite good to turn it off. And you're thinking, yes, sure, you can just redeploy, and as long as you've got a quick build process, it'll be fine. But we want something even quicker than that. We want to be able to turn it off at the click of a button. So we'll look at how we're going to do that. Another thing we want to be able to do is maybe evaluate the impact of a new feature or moving a page to React as we go along. So we want to say, today, we were able to say that when users saw the old version of the site, conversion rates were higher by maybe 5, 6, 8, 10%, say. And when they saw the React version, then maybe some things were going wrong. That wasn't great for us. So how do we do that as well? So what we decided to do is deploy each of these pages behind runtime feature flags, which sounds crazy. So that's runtime feature flags, not build time feature flags. So what this would allow us to do is flick a button and immediately revert back to the previous version of the site or previous version of a page, and also run A/B tests live where we could divert 50% of traffic to the new page and 50% to the old page. So we'll look at that, all without a redeploy, right? It's important. And the last thing we want is to minimize performance penalties. Those first 2 points largely benefit us, to be honest, as developers and as a business. We get to see how our site's doing. We get to do our work in piecewise chunks. We get to enjoy ourselves and think we're doing a great job, but that's all good. But if we're punishing the user along the way and making the experience worse, is it really worth it? Probably no is the answer, depending on who you ask. So what does this mean? Well, we want to still take advantage of things like typical SPA features like dynamic view updates. We don't want to have to make the user go back to the server every time to get a new page. So we've got to be careful that our implementation doesn't force them to do that. We've got to look at things like that first page load in React, because that can be quite costly if we haven't done it correctly. Maybe the user's going to get a whole heap of JavaScript thrown at them at once that they don't want, so let's look at how to mitigate that. And I guess we could also look at, other cunning ways of decreasing our bundle size. So the way we're going to do that is use a front-end router, React router in particular. We'll change our view based on the URL in the browser, which is fairly consistent with what you'd expect with a Rails application. And we're going to try and make use of asynchronous code splitting based on routes to decrease the big hit of that first React page. Cool. So what's our plan? That's our plan. Simple plan. A user's going to make a request to the backend. That request is going to get routed through some router in the backend, which we'll go into more detail about in a second. And X% of the time, the router will tell the user, you can go see the React page for this route. And the remainder of the time, it'll say you can see the Rails page for this route. So this is great because that fits our sort of A/B test idea we were talking about earlier. A few things about the router, though. We need to make sure that it's deterministic and consistent. We need to make sure that it's based on the user's ID. So if the same user comes back tomorrow, I don't want to suddenly show them a different page. It would be probably confusing at best and screw up our stats at worst. So we need to make sure that based on the same user, they would consistently see the same implementation. And that's probably the most important thing. And these percentages can obviously vary. So we're going to use a few tools to help us out. Now, these tools are mostly on the back end of the application, but I think they're still extremely relevant about this talk. So we're not going to spend a huge amount of time seeing how you'd actually set them and use them up, but we can talk about the concepts behind them. So one of the tools is Bandiera, which is an open source, simple standalone RESTful feature flagging service. So you would just make GET requests to this service, or HTTP requests of any sort, and it will, based on a user ID of some sort, or maybe some other information about the user, return an object, a JSON object, of feature flags. So these flags would have keys, which would be the names of the flags, and values, which are just booleans, true or false. And we'll have a look at an example of that in a second. Another tool we use is Thunderball, which proxies or redirects requests to different applications based on response from an API. Thunderball is a hyper example of the single responsibility principle. It really does nothing else. It literally just waits for some response from some other service and says, right, you're going to this application or you're going to that one. So maybe you can see how these already might piece together. Look at that in a second. In addition to this, we actually, at Nesta, we also use Mixpanel and GTM to track how the user interacts with our application based on being either routed to the React application or the Rails application. So one thing we do to make our life a lot simpler is we take the feature flags from Bandiera and we include it as part of that initial event that's triggered when the user visits our page. So when you look at Mixpanel, you'll be able to filter by users who were able to see the React homepage or users who were able to see the React how it works page, etc. So when we break that router layer down, this is how it looks. So we have a request comes into Thunderball. Remember, Thunderball decides which application you see. Thunderball will have a chat with another service which I've labeled is React there. What that means is this page written in React yet? If this page has been written in React, we'll have a look at what the flags from Bandiera say. And those flags might be true, might be false for a given route. And based on that, we'll send you to the correct page. So the scenarios you need to consider are a user tries to visit a route which isn't yet built in React, in which case it'll be false returns from this service, and then they go to the Rails application. A user might try to visit a route that is built in React, but we've randomly decided on this occasion that they're not to see it, in which case they'll go to the Rails application. And finally, a user might try to visit a page that is built in React, and they actually do get the true feature flags in Bandiera, in which case they will get routed to that. So that's how we've set up the back end to do this, to allow us to send some traffic to React application and some traffic to the old version of the page in Rails. So how do we actually go about writing these React pages? Well, this is a lot more standard, probably a lot more what you're used to. I've skipped ahead a few things here because there isn't much to see, honestly, but we've assumed that these three files are already built: the header component, the footer component, and the home component. So the header and footer component are just common components that would be throughout your whole application. So when you go to build this first React page, you'll obviously need to build those up front. The home page is the first page we've chosen to convert to React. So we're just assuming that these are already built. So they're going to look like normal React pages and normal React components. There's nothing to see there. Perhaps the more interesting thing is the fact that we're using React Router 4 here. You can see in Lang 4, we're using the browser router from React Router 4, which gives you a router which is, I guess, endowed with the HTML5 browser history API, which allows you to mimic the same sort of routes you'd see in a Rails application. So you'd have maybe / guides / how to set your house or something like that. And if you haven't seen React Router before, well, the main takeaway here is that the root component represents the things that are dynamic. So this root component takes a path, and it says when we navigate to that path, in this case just nested.com, then we'll render that component, which is the homepage component. There's no other routes, so we actually haven't written any other components yet for React. OK, so that's pretty standard, actually. There's nothing really amazingly blisteringly new there if you've used React Router before. But perhaps a more interesting issue arises when we start talking about what happens when you want to go to a new React page. Naively, this seems like it's going to be easy. Naively, I thought it was going to be easy. So what you end up with is this interesting possibility where a user might be able to visit a React page that they're not actually supposed to see. So if we just go ahead and say, right, we've got a home page written in React, we've got a how it works page written in React, we only want half our users to see the home page, and we also want an independent half to see the how it works page. How do I link between those two? So if I just use React Router link to link from the home page to the how it works page, then that is not respecting the Bandiera flags, which could independently vary as true or false for each of those pages. So you could have a user that's allowed to visit the home page, but not allowed to visit the how it works page. And if we just use React Router link, we're going to completely bypass that check that happens in the router in the back end. So we end up with a bit of an issue, which means that what we really need is our link component to be aware of our feature flags, our Bandiera flags. And a quick implementation of that, which is by no means complete, would look like this. So what we have is we assume we're getting our Bandiera flags from the API. So I'm not going to go through how to go and request those, but it's a standard RESTful API. You end up with this JSON object, which will have keys equal to the flag names that you've chosen, and values equal to true or false, depending on whether or not that flag's enabled. So what we've done here is we've set up some naming convention for these flags. So you can see our convention is to say enable page : followed by the root. That allows you to make sure you don't have to constantly update this file every time you write a new React page. You don't have to go and say, what's the flag for this page? You don't want to be in limbo doing that. So the idea is we just use a convention-based routing. So we write this new component called link with feature flag. What it does is it takes the toProp, which is the route that you're going to, creates the feature flag name from that, looks it up inside the feature flags object that we got from Bandiera API. If that's true, we render a link, because we're allowed to see the React page. We want to make sure that we don't have to do that full request response cycle. We want to dynamically update that view. If it's false, then we render an A tag because it's a non-React page, and we've got to go back to the back end, get directed to the Rails application, and then get that new page. And actually, this could also be undefined, if you're particularly astute. You might have noticed that. This could be undefined and not false, which would mean that that page isn't even written in React yet. So that's fine. We'll also go see the A tag. We should see the Rails page. So once we've got past that kink, we're actually looking OK. So we're able to release pages one page at a time. So we're able to see all the issues that we'd faced earlier, like the integration issues that you might have thought of. We're able to evaluate the impact as we work with these feature flags, so we can quickly turn things off at the press of a button. I wish I could show you the dashboard right now, but I don't think I'll be able to see it. But there's a nice UI dashboard that comes with Bandiera that allows you to just click little buttons that literally turn features on or off immediately. It's really cool, actually, switching things on or off on your site immediately. And if we set up A/B tests for this using GTM and Mixpanel, we can also evaluate what that means in terms of data and which users are actually following through and signing up to whatever service we offer, which ones hate us completely and leave immediately. You can see everything. But the last thing that remains is minimizing these performance penalties. Now, we've done some of that because we've paid attention to this link component. We could have been quite lazy and sloppy, and we could have just used an A tag for everything instead of worrying about ever using the link component. And that would have worked, but it would have sort of defeated the purpose of using React and using an SPA if you're going to go through that full page refresh cycle. So can we do better in these performance penalties? The answer is I hope so, because I've drawn a pretty biased diagram to demonstrate it. So what we have here is a user requesting a page from the back end, and as a reward for your interest in React, you get hit with all this JavaScript all at once. You get our home page, you get our how it works page, you get our customer stories, guys, research, careers, everything. On one hand, pretty cool, because it means you can navigate around really smoothly. You've got everything you're ever going to want. On the other hand, not so cool, because you've got everything you're not going to want. You may never visit the research page. You may never visit the careers page. And we've just decided up front that you need all of this, so that's not pretty gentlemanly of us. On top of that, probably more funnily, you may not even be allowed to see some of these pages. Depending on the Bandiera flags that we've set, we may have sent you code that you can't even see. So that's completely unacceptable. So what we want to do is change it to something more like this. So you make that first request the first time you come to your React page, and you'll get the home page code back, if you go to the home page first, as well as the code required to bootstrap the application and any dependencies that you might have. Then on subsequent navigations, when you go to the How It Works page or the Customer Stories page, you'll only get the code required for that page. So the idea is to split these requests up into smaller and smaller bundles. It's blank on my screen. OK. So the way we're doing that is with asynchronous code splitting. So we make a separate JavaScript bundle per root. So every time you go to a new root, you'll request the code for that bundle via AJAX request only when that root's triggered. So you don't need the code for the How It Works page until you view the How It Works page. The easiest way to do this is literally to follow React Router 4 documentation for a good approach, but we can have a go at just seeing how that would look on the example we had earlier. So there's a bit more happening this time. I really wish I had the fancy line highlighting like one of the talkers earlier, but I'm going to try point at absurdly high points in the room. So main things to take away here are that we're importing two different pages on line 5 and 6. Or are we? We're almost importing two different pages in lines 5 and 6. So we're using something called bundle loader with the lazy option. Now what that does is it creates a function, load home in this case, which when invoked will request the code for pages/home. So you're not going to get it immediately. When this import statement runs, you're not getting that code, but you'll get a function that will allow you to request that code at runtime. The same for line 6 beneath How It Works. And then we're using this bundle component that we've built. Again, recommendation from React Router 4 docs. So this bundle component, how does it work? Well, the idea is that before, when you would have passed the home component to the root, you'll now pass the home component wrapped in a bundle. So bundle defines split points in your application. These are the magic points at which we're going to decide that no code should be requested beyond here until we've rendered that component. So in terms of implementation, that means that bundle needs to take this load component that you got earlier, so the component that tells you how to require that code, how to request that code. So it takes that. When it mounts, it'll call that function. So it'll go and get the home page, and then it will render the result of it with that function that's passed as children on line 12. So if you do every route like this, the idea is that whatever path you visited when this page, when this component runs, that's the only one that will actually get rendered, and that's the only bundle component with that load function that'll get called, and that's the only code you'll request. And then when you visit a new page, you'll call a new bundle component with that new load function, how it works in this case, and that'll request some more code. So you're minimizing what's requested each time. I think I do have the bundle component. Yeah, I do. I've got the bundle component here. It's reasonably complicated, not absurdly complicated, but confusing enough. I think the main takeaways from it, I'm not going to tell you everything about it because that would spoil the fun, but the main things are that, if you remember, it gets past a load prop, which we saw before. So it gets past this load prop in line 11, so it's going to be this.props.load once we're in here. And you can see that when the component's about to mount, it'll call its own load function with the props. Our own load function's over there on the right-hand side, from lines 28 to 27. It does some state setting, which if you go through the rest of it will make sense. It has to reset itself each time. And then it calls the load function. So this function is now going to go off and request our home page, and then we get the module back, and then we set the state with the result of that module. If it's got a default export, we set it with that. If it doesn't, we just use the named exports. And then later, when this is rendered, it's going to call the function that was passed in as children, which looks like this. It's just rendering the component, with the component that was the result of requesting that module asynchronously. Now, that's quite complicated. I'm not sure I've done the best job in the world at explaining that, but the main point to take away is you can use this solution straight away, and every time you see bundle, it's going to be a separate chunk in your application, and it won't request anything inside that until it needs to. You can take this even further. You can extract vendor bundles as well. So that means any third-party dependencies can be extracted into their own chunk. You might think that's somewhat pointless because you're still going to request that the first time you visit any page, and you're absolutely right, but it allows you to take advantage of browser caching between deployments, which is pretty cool. The idea is that these dependencies update less frequently than our own code. So if we put those in another bundle, then we don't have to worry about the fact that, those will be cached by the browser, and we don't have to worry about when we redeploy our own code, it's going to make us re-download all those dependencies. So it's really cool if you can split it up into loads of different bundles, because you get maximum probability of caching as much as possible. You can also extract the Webpack runtime itself into a separate bundle. It's just this little bit of code that Webpack injects into the top of every module. That's getting pretty far into it, but actually some changes you make in your application do cause that little piece of code that's injected to change, which is really tedious if you weren't expecting a bundle to change, and it does. So that also improves cacheability. You probably want to add cache buses for development so that you're not confused about why your code's not updating when you're doing hot reload and this sort of thing. And you want to possibly look at the order of import statements and how that affects your ability to cache code, because there's some interesting behaviors there as well. You can read about all of this online, though, not here right now. A few things we glossed over, just to think about and not ask me about, is the need for a fully fledged data API. It's all well and good going out there and making your brand new spanking shiny front end. It's going to impress everyone. But chances are, if you had some server-side rendered pages before, like something like with a framework like Rails, you probably didn't expose all your data as JSON. It was probably being injected in at some point in the back end. So we were lucky in that we actually did have it as JSON in another service, and we were able to sort of expose that quite easily. But you might want to think about that before you jump in. Another thing that we ran into is sharing state between Rails and React applications. Now, this isn't something I got to work with a whole lot because it was something the back-end developers cried about a lot more than I did on this app. But I'm led to believe that it was the cause of serious mental anguish. And most of the issues come from sort of keeping state in check between the two applications and making sure that things like the user ID is communicated correctly at that point where it goes through the router. So once you're getting routed off to different applications, we need to make sure that we can still identify user beyond that point and that we're not getting confused about who's who and perhaps getting different Bandera flags as a result. Cool. So that's everything. Hopefully that would give you some direction on where you could move a multi-page application to React. If not, feel free to ask me any more questions now or later. Thank you very much.
Do you have any questions for Tyler? Over here, straight up.
Hi, I have just a quick question. You were talking about different apps to manage any single page, but the goal, I guess that as you're talking about a single page application, at the end you're going to merge in a single application, or you want to maintain in this way different apps?
That's a good question. We do not want to maintain this forever. It is effort. Yeah, this is more, the idea is definitely to be in one application by the end, and in fact, the application that we want to be in is that one. We want to just have a React application at the end of all of this. Yeah, we've got no interest in maintaining that Rails application forever. The idea was, though, to make our changes as we go along, so we don't want to just do it in one sort of big bang all at once and declare that everything will be fine. We want to actually do integration along the way. We want to make sure that it's not affecting our site. So yeah, we're going to have one application by the end.
Okay. Now, because my question is, it could be possible to have different projects that are managing the different apps. Are you having one single repository to manage the single apps, or you splitting it on different repositories in the way that you're working like in microservices, in the way that when you change something on a single page, you're not affecting changes on the old pages?
Yeah. It's completely separate projects. Yeah. So these are two completely separate applications. This React application?
No. But my question is more on the React apps. I mean, you're creating different apps for each page.
We're not creating different. No. Hold on. We're not creating different apps for each page. Maybe that wasn't quite clear. Sorry. So when we start using React Router, we're actually using one app for each page.
Okay.
We're getting React Router to do the bridging between those pages. Sorry, I might have scooted across that quite poorly. So it is one React application. Absolutely.
Okay, so it's just split between bundles, but it's one single app.
Correct.
Okay.
Yes. Sorry, that might not be quite clear. So when I say to split things into bundles, it's just about when that code is requested. It's not actually a different application, but you're building in some intelligent logic into your application that says, I don't need that code until I get to that page, and then you get that code. Okay. It's not a different application. It's just like requesting more data from an endpoint, for example.
And more or less, how many pages is nest.com? I mean, you're going to create different bundles, and how many bundles are you going to create? More or less, I mean, and not specific number, but.
About 10, I'm being told. I would have said about a dozen, baker's dozen. So maybe about, I don't know, maybe about 15 pages, I think, right now, or 20, I'm not sure, based on the last spreadsheet I saw. So we could end up with maybe 15 bundles by the end of it all, yeah.
Okay.
Yeah.
Thank you very much.
No problem. Cheers.
So I've got a quick question.
Yeah.
So is there any repetition between all these bundles? I mean, there's going to be different pages that are going to use similar code that's going to get bundled in each one of these bundles, right?
Is there any repetition between the bundles?
Yeah. So
yep. So if you were to do this just like that, yeah, you'd probably end up with a lot of repetition. You'd probably end up with some components getting bundled into each bundle. If you have any sort of common components, like, I don't know, generic buttons, for example, you don't want to include your own button every time in every bundle. So this suggestion, as you've just pointed out, actually probably isn't a suggestion at all. It's probably completely requisite. I said extract vendor bundles. You can also extract any of your own common code as well. And it's pretty much the same step as extracting vendor bundles.
Then aren't you going back to the problem of having multiple requests or simultaneous requests and slowing down the browser and losing the whole point of having one big bundle in the first place, right?
So you're saying if we end up making loads of requests, what's the point in using a front end? What's the point in using a single page application?
No. If you're making loads of requests to download all this data, using all this bandwidth and multiple requests happening at the same time, you've got the browser limitations of how much you can download with images and all the rest of it.
Yeah.
That was the advantage of having a big bundle to just get all that in one go and
get
done with it.
I don't think anyone would claim that, because obviously the disadvantage of having the big bundle on one go is you get a lot of stuff you may not need. There's two sides to that coin. So on one hand, you get stuff you don't need. On the other hand, you're going to be making more requests that could be slightly more tedious. It's about trying to sort of find the right balance.
So there's a balance there. And as you say, you get the advantages of using cache and that kind of stuff. So
yeah, so it sort of swings around about. In our case, we deploy every time a pull request is merged into master. So people might disagree with me on this because it probably depends on how many site visitors you get revisiting and stuff, but I think the value of getting caching between deployments is actually quite valuable to us because we're deploying so often. But you may find in other cases that actually that first request is not so much of a problem. The other thing to add on top of that is these are all independent requests. So actually you might be able to show something sometimes. In the case of common components, probably not. But you might be able to show something sometimes before the other requests have complete. And when it comes to things like a marketing site that we're trying to get, that can matter. That first page load time can be actually a big deal in turning off a user or keeping them on your site. So that's quite interesting. But yeah, good question, for sure.
Cool, thank you.
Thank you. My question is about the SEO.
Okay, thanks. Is that a plant? Yep. No, go ahead, fine, yep.
Because you change to the client side, isn't it? Is everything rendering in the client side? So you drop the SEO?
So I didn't admit something along the way, which is we're not showing exactly everything we did. So this is a good overview of what we did. A lot of it follows very closely, a lot of principles we're following. We actually do server-side rendering. There is no way I'm going to squeeze that into this talk as well as the other stuff. So we do have server-side rendering going on as well for SEO purposes. But we did an experiment along the way, and we found some pretty interesting results about SEO and client-side rendering. And there may be some edge cases that we don't know about, but as far as our tests were concerned, you were able to do fully client-side rendered sites with asynchronous code splitting, with actual content management systems as well. So you're actually getting some of the the text and stuff that populates your components from a different API. Was there anything else in there? Using React Router as well, part of the async code splitting. And Fetch as Google, the tool that you can get from Google Console, all rendered the test application fine. I didn't fully try it on this application because we had already sort of committed server-side rendering, but I think the jury's still up about that. It's worth looking into some more. But Fetch as Google's a great tool. It sort of lets you see how Google actually indexes your page when the crawler comes along.
Thanks.
Thanks.
I have a quick question off the back of that.
Oh, brilliant. Yeah.
Are you rendering isomorphically as a separate node application, or are you actually rendering in like V8 using Ruby Runner or Ruby Racer? Or
We have a separate node application.
cool.
So in reality, this split is more Rails node.
Actual
Yeah.
services, yeah, brilliant. Cool. Any more questions? Oh,
Good.
great. God. I'll go over here first, so it's closer.
Thanks. Interesting talk. I'm doing something similar at my work, but it's a PHP backend. In our case, we're still serving the React applications, React pages through PHP.
Mm-hmm.
And I was interested to hear a bit more about like what the dev experience is like, and whether you're using Webpack Dev Server within that, and like your hot reloading and stuff.
Yep. So what sort of the front end of the application, you can pretty much draw a box around that React box, and I've lost you. There you are. And that's it. So we do use Webpack Dev Server there. So when it comes to developing front end features, we're not messing around the rest of this. This is sort of production stuff rather than development stuff. Yeah. So development process is great, just as normal. Yeah. Cheers.
I'm coming over to you 1 second, and then that'll be the last one, I think.
Okay, I did have like 5 questions, so I'll try and limit myself.
I'll just keep lying and pretend I know what I'm doing. It's fine.
Cool. So if you're doing a server-side render, do you solve the code splitting problem? Do you take into consideration the routes that you've split over when you do the server-side render? Because I know that that's a common problem. And if you have, how have you done that? And the second question, quick one, is how come you did the feature splitting logic in the server? Why didn't you just do that in the client?
Fair question. So are you saying, so we'll do the last question first. Are you saying that you could do the feature splitting logic in the front end and then just redirect the user back to some route, which is a Rails page then? Because we need to get to the Rails application at some point.
Yeah, but it's this client that's making the decision about whether it gets to the Rails application, isn't it? So
in this implementation, it's the back end making the decision.
I thought that there was the link component.
There is the link component. So, so
using the
okay.
feature switch.
Yeah. At that moment, why don't we move all the decision making to the client? Is that what you're saying?
Yeah, because I guess it could just all be there in the client, right? Because you said there was a request happening. I mean, that's I'm more interested in the other question, to be honest.
I'll focus on this one. So if you imagine you're on a Rails page, and you click a link, so none of this is obviously single page app, none of it's React aware. That's just going back for the server. So at that point, we've got to decide where you're going. So I suppose it's more that transition than the other transition that matters. What was the other question? Was it server-side rendering?
Yeah, so on server-side rendering, you got some code splitting going off, and I'm guessing that's happening per path or something, per route, which I think I saw. So when you do the server-side render, do you actually server-side render that's code split chunk, and how do you do that? Because I know you were doing some Webpack specific stuff.
Yeah.
And obviously Node can't deal with that, right?
So if you go on the React Router 4 docs, and you scroll down in the section about code splitting, you get to the very bottom, there'll be a warning saying, don't try to do server-side rendering with this.
Yeah.
Yeah. So bearing in mind that I wasn't planning on talking about server-side rendering, I decided to show this in React Router 4 because it's more declarative, it's a lot easier for me to explain. With React Router 3, if you just take a step back, he's pointing at me, he knows. Look at him, testing
That's
me.
up now, right?
React Router 3, you can do both. So that's, we have not solved, Fermat's last theorem here. We haven't done something no one else has done yet with this. This is still, a problem for sure.
I'm just making my way over here. There's one question over here somewhere. Brilliant. Cool. Last question, I think.
It's an easy one. Please.
Yeah, it's an easy one. So yeah, just to set the presentation in context, how many users do you have per month and page views? And I think what I'm getting is what's a good watermark to kind of try to implement this kind of setup for a website?
Sure, okay. So we only launched the site live. The business has been going for, I think, probably just over a year now. But we only launched the site back in September, October, I think. So at the moment, I think we get anything up to maybe about 1,000 unique users a week at the moment, which is 4,000 a month, I guess. So how this scales beyond that? Well, I'm hoping we'll have moved to the full React solution by the time that happens. If you are BBC News and you want to give this a go, probably have a think about it first. Let's see how it turns out. You can have spikes of a few 100,000. But yeah, the question is, I don't know. The answer is I don't know in practice how this would do for large, huge amounts of users.
Thanks.
Thanks.
Let's give Tyler a massive round of applause. Thank you, Tyler.
Cheers. Thank you.
It's hot, so we're going to go to the pub and cool down with beer, I think, after this. So don't forget, if you'd like to submit a talk, you can go to meetup.react.london, and there's a hashtag React London. Join the Slack channel, Red Badger's hiring. Thank you very much. See you next month.